Hello, welcome to Pakibi TV. In this video, I will explain the meaning and importance of Euclidean geometry. To put its meaning simply, it can be described as the completion of the mathematical system. Let's delve a bit deeper into this. The question of this video is this: what is Euclidean geometry? Why does everyone mention it? Why would such a question arise? It's because you'll definitely come across Euclidean geometry when you study about what math is, what the history of math is like. If you're interested in mathematics, you've probably heard about it once or twice. Why is it so famous? Because it's important, of course. Then why is it so important in mathematics? The reason is that Euclidean geometry has established and presented the system of mathematics. For more information about the systematic nature of mathematics, please refer to this video. Euclidean geometry is a system of mathematics that was established 300 years BC or 2,300 years ago from the current year of 2000. It determined the way of thinking in the field of mathematics. It essentially presented what we call mathematical thinking. Mathematical thinking is, at its core, a logical system where all knowledge is strictly derived from a few self-evident propositions. The systematic characteristic of mathematics is represented by the math triangle that I've drawn. It can be drawn like this. In the math triangle, the few self-evident propositions from which all mathematical knowledge is derived are at this peak. In Euclidean geometry, these are composed of 5 postulates. Now let's delve into the system of Euclidean geometry in more detail. What we should always remember is that mathematics is a logical system, and all knowledge is strictly derived from a few self-evident propositions. The 5 postulates in Euclidean geometry are as follows. It's primarily important that these are self-evident, and it's also important that there are only 5 of them. Being self-evident means that it's so obviously true that there's no need to ask for further justification. For example, if you look at the first postulate, there is only one straight line that can connect any given point to another, right? At first glance, there's no doubt about it, is there? It's so certain that there wouldn't be anyone asking, why is that? This is what it means to be self-evident. The second postulate is the same. If you have one line segment, you can extend it as much as you want. The third postulate is equivalent to saying that you can draw a circle. You can draw any circle, right? The fourth postulate is also very obvious. The fifth postulate is a bit long and complex in explanation, but it means this. You'll understand it quickly if we draw a picture. Like this, if 2 straight lines intersect with another line, the sum of these 2 angles on one side would be less than 180 degrees, wouldn't it? Then if you extend this side, the 2 lines would intersect, right? Here it is possible for both to be exactly 180 degrees, then they won't intersect on either side. In this case, the 2 lines become parallel. So we call the fifth postulate the parallel postulate. Later, the term postulate becomes axiom, and a system of knowledge or thought, like geometry, is referred to as an axiomatic system. Now this has become the representative name for the mathematical system of thought. I'm going to mention some historical trivia about Euclidean geometry. Many of you may already know this. Firstly, Euclidean geometry was written in a book titled Elements. The cover of the first English translation looks like this. It is the world's first math textbook. It became the model for Western logical thought and, to emphasize again, the model for a systematic body of knowledge. If you look at the picture we saw earlier, it was completed around the 3rd century BC, 2,300 years ago, and is composed of a total of 13 books. For the detailed content, please refer to this video. The content of Euclidean geometry was considered the absolute truth about the world in the West for nearly 2,000 years. This lasted until the appearance of non-Euclidean geometry in the 1820s. In summary, Euclidean geometry was the model of mathematical thinking. This way of thinking is still maintained today, so it can be said that it is very important in understanding mathematics. So far, I have explained the mathematical importance of Euclidean geometry. If this video was helpful, please hit the like button and subscribe. Thank you.